Daniel, if you're looking for a reference, it's this little page right here. I forgot to unfreeze my screen. So you have your formula sheet. And I think I told you yesterday, we're not going to be really doing any new formulas on your formula sheet. There might be an extra one on there. I got to look that I'm not going to get to that I might cross off. Nope. There you go. We've done them all in electric circuits. Reminder, and especially those that were away, we crossed out the bottom row of electrostatics. So those four under electrostatics that say E equals delta V over D, that row there, we crossed that out both on the blue and on the yellow sheets. But the other thing that you want to know is lesson 7, this little thing right here, steps for solving circuits. That's also something you might want in front of you for the remainder of this unit. This is Mr. Dueck's handy dandy guide to solving circuits. We're going to be looking at mixed resistor circuits. What are mixed resistor circuits? They have some parallel and some series. How do you solve them? Step 1, I've already tried to teach you. Label downhill. Also, while you're labeling downhill, your eyes are moving through the circuit. Sadie, you're just getting a good feel for what the circuit entails. I think that's worth doing. Step 2, you want to try and find the total current leaving the battery. If you can find the total current leaving the battery, I'm telling you, the question's going to fall apart. Step 3, look for any places in the circuit where you know 2 things. Knock, knock. If I know 2 things, I know 4 things. Step 4, ski using Kirchhoff's laws. Start on the chairlift if you know the chairlift battery height. Ski a complete closed loop. If you end up back at the bottom of the chairlift, whatever voltage you gained, as long as you keep going downhill, you must have lost. 5, as a last resort, rewrite the circuit in its simplest form. There will be one question on your test at least one, that I've contrived where you will have to do step 5, but a lot of them you can just get away with steps 1 through 4 and Kirchhoff's laws and solving. Example 1 says, identify resistors in series or in parallel. Do me a favor. Can you label this top one R1, R2, R3? Which resistors are in parallel? Okay, now if I wanted to combine these, the first thing that I would do is I would go 1 over R parallel is 1 over R2 plus 1 over R3, and then R total would be R1 plus R parallel, because I would have replaced this with a single resistor, and it would be in series with R1. So then I could just go to my adding method. Pause for a second. In this second diagram, you know what? Let's call this R1. Let's call the middle one R2, the top one R3, the right one R4, bottom one R5. Here's the question. Which resistors are in series with each other? So I'm glad Dan made that mistake. Dan said R1, R3, R4, and R5. Our official definition of series was no junctions between them. Is there a junction between R1 and R3? R1 is not in series with anything right now. Which ones are in series? Sorry? No, R2, there's a junction right there. R2 is not in series with anything. Raj. These are in series with each other. If I wanted to, I could combine those as one resistor because there's no junctions between them. But I can't combine them by adding if there's junctions between them. So what I would do is I would add R3, R4, R5 together as a single resistor. And you know what I would have just done? I would have turned it into this question. Because now I would still have R2 sitting right there. R3 would be the combination of R3, R4, and R5. And that's really going to be a lot of our strategy, is turning it into one we already know how to solve. Ooh, what about here? Well, let's call this R1, R2, R3, R4, R5. Is R1 in series with anything? No, there's junctions between it and everything. So it's a nothing. Can you tell me, Jonah, two resistors that are parallel with each other? Yeah. I could combine those by going 1 over R2 plus 1 over R3 and then reciprocal button. Okay? Can you tell me two more that are in parallel with each other? I could combine those by going 1 over R4 plus 1 over R5 equals reciprocal button. I could turn this diagram into a circuit that looked like this. Single battery, one resistor, one resistor, one resistor. I could turn it into that. Now, those three mathematically equivalent resistors, how could I combine those? They're in series, so just add them, okay? We're going to do examples with numbers, but I'm just giving you the concepts right now. Let's suppose, Kira, this was R1. Let's go R2, R3, Mr. Dueck, R2. Let's go R3 below it, and R4. I like this question. I like this concept. So which ones are in parallel? Some people might say R2, R3, and R4 are in parallel with each other. They are not. So there's kind of a bedmass order of operations. If you have resistors in series, combine them first. The first thing I would do is I would combine these as one resistor. And do you know what it would look like then? It would look exactly like this circuit. I've turned it into one I've already seen. Okay? So it's going to look a little weird in the notes because I've been talking, but you can make a little note. R2 plus R3 are in series, and then you could combine 1 over whatever R2 plus R3 is plus 1 over R4 equals reciprocal. Let's do some with numbers. Example 2. This one here, I would consider a C plus question. It says find all voltages, current, and power usage. All right. What was step 1 in that little 5-step program that I gave you, labeled downhill? That's the positive. That's the positive. I guess you could say downhill was clockwise. By the way, which way are electrons actually flowing? Counterclockwise or anti-clockwise? Like the British say anti-clockwise. Step 2, try and find the total current leaving the battery. Do you see amps anywhere in this question? Okay, but I would try that next. Step 3, ski. Okay, oh, sorry. Step 3 was look for two things. Do you see any resistor that has two things? Okay. Step 4 was ski. How high is the chairlift, Shko? How many volts do I gain? How many do I lose going through here? Don't know. How many do I lose going through here? Uh-oh, I have two hills. I don't know. That didn't help. What if I ski the outer run? Don't know. Don't know. Ooh. By the way, which two resistors will have the same voltage loss? The 10 and the 15. Okay. So if I know one of the voltages, I can walk it over there. My last resort, I'm going to have to combine this. Okay, I'm going to combine this. I'm going to be lazy but organized. Which ones are in parallel? First thing I'm going to do is I'm going to go 1 over R parallel equals 1 over 10 plus 1 over 15. You know what I would probably do, actually? If you write that, you're fine. I might do that over here, just kind of in the area of the resistors I'm combining, if I have room. So I might go 1 over R parallel equals 1 over 10 plus 1 over 15. And then I might say, okay, R parallel is, what do you get? I don't think you do. You forgot to hit the reciprocal button again. By the way, handy error check, okay? How big is this resistor in ohms, Mesa? How big is this resistor in ohms? When you're combining resistors in parallel, your answer will always be smaller than the smallest resistor in your group. I knew the answer was going to be less than 10. In other words, don't write this down. If there was a third resistor in parallel and it was 2 ohms, then an answer less than 2 would be acceptable. I would, in fact, try that right now just for giggles. Go 10 reciprocal plus 2 reciprocal plus 15 reciprocal. Guarantee you're going to get an answer less than 2. Oh, and reciprocal the answer. Try it, please. Okay. That's a handy error check. It's kind of weird. When you add a resistor in parallel, you actually lower the total resistance. And that's, wait a minute, I'm adding resistance. Yeah, you're opening up another ski run. Overall, we can get more skiers on the hill. Okay. Anyways, what was the correct answer for R parallel? I've forgotten. What did you say it was? 6. I'm going to do a quick re-sketch then. And this is a sketch. You don't have to do a fancy schmancy circuit diagram. My sketch is, okay, so we have the 20-volt source. How many ohms in the top resistor? I scroll down. 4. And then this is the mathematical equivalent of a 6. Okay, now I'm good to go. They want me to find everything. First thing I'll find is R total. What's the total resistance of this circuit? And in my notes, I'll write 4 plus 6 on a test or a quiz, right? So I know what numbers you're using. In your homework, if you go straight to the 10, I'm fine with that. But just so we know what we did. Why does that help? Because I total equals V total over R total. Ha, I can do this in my head. 20 over 10. What's the total current that's flowing through this circuit? This question's going to fall apart. I would probably, as soon as I find the total current, what I almost always do is I go walking back to my fake circuit and I say, okay, that's 2 amps. I go walking back to my real circuit. I say, okay, that's 2 amps. In fact, how many amps are flowing through this 4 ohm resistor, Kira? Got to be 2. I would write that there and I would smile. I would say, knock, knock. I know 2 things. I can now tell you the voltage drop there. V equals I times R. It's going to be 2 times 4 in your head without a calculator. Show off. You're correct. Say that again. How many volts? Okay, then how many volts must I lose in this 10 ohm resistor for this circuit to work? 12, right? See the ski, 20, lose 8, got 12 left. Ooh, how many volts do I lose in that 15 ohm resistor? Because they're either, you could either say because they're in parallel with each other, or you could do the outer ski run. And now for both of those, knock, knock, I know 2 things. So I can find the current here. It's going to be, oh, it's V over R, because V equals I times R. So it's 12 divided by 10. I can do that in my head, 1.2. And then I could either go 12 divided by 15.8, or I can say, wait a minute, I got 2 amps, 1.2 amps went down the middle, 0.8 amps must have gone through the other one. The last thing it wanted us to do is find the power usage. We got room, so let's do that. Power equals V times I, or I squared R, or V squared over R. I'm going to go V times I. This is going to be 16 watts, is that correct? And yeah, and then 12 times 1.2, 14.4 watts in the middle one. Double check me. And the right hand one, it's going to be 12 times 0.8, 9.6. Okay. Which of these resistors will be giving off the most heat? The top one. Or if I told you they were all light bulbs, these would be really small light bulbs. Which of these is the brightest bulb? My mom says I'm not the yeah, I know, she means something different. Which of those is the brightest bulb? Top one. Or which of those is the dimmest bulb? The one on the right. Okay. A good using principles of physics follow-up part B question would be something like this. Suppose I pull out this light bulb and remove it from the circuit. Will the 15 ohm bulb get brighter, dimmer, or stay the same? And all you would do is just cross out this resistor, resolve the circuit, and see what you get, see which one has more power or less power. Did we find everything? Voltages, currents, and power? Yeah, we did. Okay. That one was a C+. This one, B-, a little tougher. Find all voltages, currents, and power usage. Mesa's kind of going, eh. Mesa, here's what I'm going to argue. I can turn this into this question. You know why? These three here are in series with each other. I don't see a 12 and a 6 and a 2. I see a single 20. I added them because they're in series. 12 plus 6 plus 2. This is the same mathematically as a 20 ohm resistor. In other words, the first thing that I might do is I might go, okay, this is like a 30. There is a 6 ohm there. There is a 5 ohm there. But I'm telling you that right hand is the same as that. Again, you'll notice, Raj, I'm being pretty casual in my sketch here, but it is worth sketching this out and not trying to do this all in your head. But now, does this not look identical to the one we just did? Different resistors, but the same pattern. A single that splits up into two. So, okay, here we go. It's going to be 1 over R parallel equals 1 over 5 plus 1 over 20. Shko, you're going to tell me what R parallel is. I know the answer is going to be less than 5, but it's not going to be a decimal less than 1. Very unlikely. How'd you get that? 5 reciprocal plus 20 reciprocal equals reciprocal, but okay, so what I'm hearing from you then is, and I'll do another really quick sketch. This is really a 6 ohm and a 4 ohm. That top circuit is mathematically equivalent to this. Well, now it's going to fall apart. Dan K, what's the total resistance of this circuit? Yep. What's I total? Well, that's going to be V total over R total, 30 over 10. Mr. Dueck, is the answer always 3 amps? No, these last two I contrived from each other. What was your question, Dan? It's a good question. You sure? Okay. How many amps are leaving the battery, Declan? And I would probably, because it takes 1 second, go, okay, that's 3 amps. That's 3 amps. That's 3 amps. I start to fill in my original circuit. If I need to drop down to the rewrite versions, I will. But, oh, okay. 3 amps. How many volts do I lose going through? Because knock, knock, I know 2 things. How many volts do I lose going through that top resistor? 18? Ooh, ski with me. This ski run here interests me. How many volts must I lose going through the 5 ohm resistor? Got to be 12, right? Start with 30, lose 18, 12. That got me to the bottom. Oh, as soon as I write that down, knock, knock, I know 2 things. I can tell you the current in that 5 ohm resistor. It's going to be 12 divided by 5. 12 divided by 5 divided by 10 and then times 2.4. Oh, Kirchhoff's rule for current. How many amps are going through this 12 ohm resistor then? Don't write this down. Wait a minute. How can I be getting 4.8 amps out when I only have 3 amps coming in? Not 2.4. How many amps must be going this way? Sorry? How many amps are coming in? How many amps went this way? How many amps are left over for here? Yes. Oh, how many amps are going through this 6 ohm resistor? 0.6. How many amps are going through the 2 ohm resistor? Knock, knock, I know 2 things. Let's just find the voltages. I'll assume that you can go V times I and find the power, but it's cluttering up the diagrams, and I don't want them to be too cluttered. So where it says power usage, just scribble that out. I will almost certainly, the question on the test will just say, find the power flowing through the 6 ohm resistor on the right, or you know what, I'd probably say find the power through the 2 ohm resistor, because I would know you had to find everything else first. How many volts in the going through the 12 ohm resistor? 7.2, I times R. How many volts going through this right-hand 6 ohm resistor? And then I could either say, you know what? This adds to 12, so these three have to add to 12 volts. I could go 12 minus 7.6 minus 3.6, sorry, it's minus 7.2 minus 3.6, or I could go 0.6 times 2. It's 1.2 volts no matter what, right? Yeah. And you're probably hearing some enthusiasm in my voice. I love solving circuits. These look, to me, little Sudoku puzzles. I find these kind of almost Zen therapeutic, relaxing brain teasers for me. Oh, here's a nice question. What happens, here's a nice using principles of physics question. What happens to the total current in this circuit as measured by the ammeter? In other words, the total current leaving the battery when the switch is closed. You know what I think I'm going to do? Open, closed. I'll do kind of a before and after. When the switch is open, no charges can flow. It's as though this part doesn't even exist. Don't scribble over yours, but I'll do that in my head. I would imagine that. Okay. Well, that 20 and that 5, how are they related? Series or parallel? Yeah, they're series now. So, you know what? Easy peasy. What's the total resistance when it's open? 25. What's the total current when it's open? Well, that's going to be V total over R total. It's going to be 100 divided by 25. 4, yes? Okay. What happens, and by the way, I think they probably have, gets no change, increases, or decreases. Let's find out. There's our options. When we close the switch, now that 5 and that 10 are in what type of resistance? In parallel. So the first thing that I would do is I would say 1 over R parallel is 1 over 5 plus 1 over 10. What's R parallel? Don't forget to reciprocal your answer. 5 reciprocal plus 10 reciprocal, reciprocal. 3.3 repeating? So then what's the total resistance? These two are the same as a single 3.33 repeating. So what's our total? 20 plus 3.3 repeating. Yes, good, Shko. Our total is going to be, I'll write in our notes 20 plus 3.33, which is 23.3 repeating ohms. Okay. What's I total? V total over R total. V total still 100. R total 23.3 repeating. Oh, I got a typo. I did 10. 100. Kira, what'd you get? Let's call it 4.3. We'll do some rough rounding. Here's the question. When we close the switch, did the current go up or go down? What was the original current with the switch open? 4 amps to 4 points. So correct answer, increases. There's my proof. Now, sometimes instead of giving you a question with numbers, they might just have put R1 right there, R2 right there, R3 right there. Make up some nice numbers and crunch it. You can do these intuitively. So here's what I would have done, because I've done a lot of circuit solving. I would have said, I know that when you add a resistor in parallel, R total goes down. I would have said, you know what? If R total gets smaller, see this little equation right here, I total goes up. Which also makes more sense. You can think of it two ways. You're opening another ski run. You can fit more skiers on the slope. Or you can also think about it, you're powering another device. You're going to need more current. Yeah, you are. Of course you are. You'll bleed the battery faster. That's it. I'm going to be giving you lots of practice. Tomorrow, Friday, I'm not going to be doing any lesson. We're going to press pause. That's going to be a day. Your goal by the end of tomorrow, Friday, is to be completely caught up so you don't have homework for the May long weekend. Okay? So, try number one. Was there a question, Sadie? You sure? Because they usually ask good questions. Okay, try number one is good. 2 is good. 3 is good. 4 is good. All 4 wants you to do is find the total resistance. If you want to, you can assume the current is going to the right. It also works if you assume the current is going to the left. It really doesn't matter, but I've told you label downhill, so pick an arbitrary downhill. You'll get the same answer no matter what. 5, I'm going to put a star next to. 5 is weird. Look at it. What's weird about it? The battery's in the middle. I probably won't do that on a test or a quiz, but you know what? You can handle it. 6 is good. Ooh, they're asking me to find the cell voltage. Hey, wait a minute. Did they give you 2 things somewhere? I bet you I won't need to rewrite that. That's kind of how I roll. If I see 2 things, I'm almost guaranteed I'm not going to need to rewrite it in its mathematical equivalent. I can probably just solve it with Kirchhoff's laws and a bit of cleverness. 7 is good. 8 is good. Stop there.